Alright, wanted to record one last video. This is basically part 2 of what we'll be doing in class on Monday, December the 8th. I'll be recording this problem right here. It says the average math SAT score at Wilson High School is 520. The mathematics faculty believes that this year's class of seniors is the best the school has ever had. 175 seniors take the exam and achieve an average score of 531 with a sample standard deviation of 96. Does this performance provide good statistical evidence that this year's class is superior at the 5% level? Alright, well again, 4 steps to go through. So I'm going to go through every single step individually. Step 1 is called name the test. Again, you don't need to write this, you just need to write what's happening. So this is a t-test because the standard deviation of the population is unknown. Okay, I'm changing this yellow. It's too difficult for me to see what's going on. Second part of this step is you need to tell them what exactly is it one sample or two sample? Well, this is one sample. I'm just comparing this year's group is the only sample I'm talking about. What I'm comparing it to is everything else. I'm not comparing it to another sample. Number 3 is I need to define. So this is mu. What should we call it here? Let's go back to the problem and read it. Maybe mu current. We'll call it the average math SAT score for this year's class. So the first thing you need to say is this. This is the second thing you need to say, whether it's one sample or two sample. This is the third thing, the parameter. And the last thing is the null hypothesis is that the current equals what they used to have. What did they used to have? 520. And the alternative is that the current is greater than 520. Alright, that's step 1. Name the test. Step 2 are the conditions. Well, that it's a random sample since every person was selected. Every person was selected. This was a census. So each person was sampled. No need to talk about independence here because, again, there's only one sample. And since everybody was sampled, there was clear independence. So, yes, independence. Independence since each student was sampled. Really, though, this independence thing could have been left out because this is only one sample. What you cannot leave out is that since n equals, how many students? 175. And this is a large number. The central limit theorem applies. Central limit theorem applies. And the data is normally distributed. And the sample, I should say, is normally distributed. All right. Step 2 was conditions. Step 3 is the math. So remember, the t-stat is equal to x bar minus this over standard deviation of x bar, which is really x bar minus mu naught over s over square root of n. Remember, this is given to you on the formula sheet. Let's plug in what we know. X bar, that's the standard deviation for this class, is 531, minus the null hypothesis we had was 520. The S standard deviation is 96 over square root of 175. What does this equal? Let's just go to the calculator. I'm not going to do this. I'll do it on both calculators. Why not? So on the 8384, you go second. You go to stats. You go to tests. You go to t-test. By the way, I'm following this part right here. The statistics are given. Right? The statistics are given. I'm going to tell it this is stats being used here. The original hypothesis was 520. The new x bar is 531. The standard deviation is 96. The sample size is 175. The alternative is that we're greater. Let's calculate. The t statistic is 1.5157. 1.5158, call it. And the p-value, I'll just go ahead and write it down right now, equals 0.0657. And the alpha, what is the significance level? Well, it tells me in part A, 0.05. On the Inspire, let me come in a little bit here. Home. Go to the calculate screen. Go to menu, statistics, stat tests. Did I go to regressions? I must have stat tests, t-test. We're putting in not the data this time, but statistics. The initial was 520. The x bar is 531. This is 96. This is 175. The alternative is that we are greater. Syntax. Oops, I plugged it in under there. Let me clear everything out of here. Wait a second, folks. How do I do this here? Okay, let me go home. Let me just make a new document here. Sorry, we had a little calculator. There's no worries there. Add a calculator. Let's go menu, statistics, stat test, t-test. Put in the stats. 520, 531, 96, 175 is that we are greater. And the p-value is 0.0657. Alpha is 0.05. And the t-stat 1.158. 1.51. 1.5158. Very good. Great. That's the math piece is now done. And now the last piece is the conclusion. So I would say since the p-value of 0.0657 is greater than 0.05, then we fail to reject, which is the same thing as saying accept. Remember, statisticians love to say fail to reject the null hypothesis, and we conclude that the null hypothesis is true, because remember, we're basically accepting this, that the current math scores on the SAT are equal to 520. You conclude that the average SAT math score for this year's class is 520. So there you go. There's again the 4-step process. So that is part A. Now we need to do B. Interpret the p-value. Interpret the p-value. So what does this p-value mean? So the p-value is basically saying what? The p-value in this situation says, what is it is the probability, the p-value is the probability that students whose average is 520. In other words, whose average was the null hypothesis. The p-value says if this is the average, 520, what is the probability that students got above a 531? So the probability that students whose average is a 520 got above a 531. That's the p-value. That's what the p-value is saying. It's saying what is the probability that if the average had been 520, that students got above a 531. That's what we're saying here. C, would the conclusion change if alpha was 0.1? So if alpha is 0.1, then the p-value of, what was the p-value we got? The p-value we got was 0.0657. Of 0.0657 is less than 0.1. Thus, if the p-value, is less, the p-value is less, then what do we say? Then there is then the p-value is less than 0.1. Thus, we have significant, we have to use the word significant. We have significant evidence to reject the null hypothesis. So we reject this and conclude that the mean score is above 520. To reject the null hypothesis and conclude the mean score is above 520. Above 520. Part D, if we made this a two-tailed test, would our conclusion change? No. Right? Because if it's a two-tailed test, D, no. If two-tailed, then alpha over 2 is 0.05 divided by 2 is 0.025. Our p-value of 0.0657 is greater than 0.025. Therefore, we fail to reject. Nothing changes. Fail to reject. Okay, and I should put and conclude mean score equals 520. All right, long problem, complicated problem, but we can